So we were looking for zeros here of 2 cosine 3 theta, and we said cosine of 3 theta is equal to 0. And then you ask yourself, okay, when is cosine 0? Well, cosine is 0 when the angle is equal to pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So anytime it's at the pi over 2's. And so you set it equal to that. Now, how many of those do you do? Remember, at the end, you have to divide by 3 in order to get the value of theta, not just 3 theta. So you have to do as many as it takes so that after you divide by that coefficient, you have all of the possibilities from 0 to 2 pi. Does that make sense? Okay. So there is no set number. It just depends on the period, whether it's 3 theta, 5 theta, 7 theta, 2 theta. Okay? Yeah.
So you did, it's all the way to 2 pi?
This has to be, this here, when you do pi over 6, like these, are all the possibilities from 0 to 2 pi.
And above?
And above, you just have to do as many as needed so that when you divide by 3, you get all the possibilities from 0 to 2 pi. You just have to try them out. So for example, let's say you stopped here, okay? And you divide by 3 and you got 7 pi over 6, okay? Where is 7 pi over 6? Well, it's in this quadrant. But you see how like there could be so many more until 2 pi? So you just have to see, okay, if I do one more, what do I get? So now suppose you did 11 pi over 2 here, and you got 11 pi over 6, and you're like, okay, am I done? Well, I don't know. Let's see, what would the next one be? 13 pi over 2, what would that give you? 13 pi over 6, which is greater than 2 pi, right? So you know you don't need that, okay? All right. So we found symmetry, we found zeros. Okay, let's find maximum R values. All right, to find maximum R values, you need two things. First, you need the location. For what angle is this a maximum? Then you need the actual value of the radius, okay? So, first you need the location. And the location is, you ask yourself, okay, this is a cosine function. You ask yourself, cosine of theta is equal to plus or minus 1 at what theta? Well, at theta equals 0, pi, 2 pi, and so on, right? That's where cosine is farthest from the x-axis. So you say, okay, 3 theta is 0, 3 theta is pi, 3 theta is 2 pi. So theta is 0, pi over 3, 2 pi over 3. Okay? How many of these do you need to do? How many petals do you have in this problem? 3. So you do as many as you have petals. Okay?
Wait, what about like 3 times? Oh, as many as you have petals.
As many as you have petals. So now, this is the location. So theta is a maximum at 0, pi over 3, 2 pi over 3. I get it. At those points, it's the farthest away. But how much is that farthest distance? You have to plug it into your function. Okay? So now, the maximum R value, okay? When theta equals 0, cosine is at positive 1, right? So when you plug it into the function 2 cosine 3 theta, how much is R? 2. When theta equals pi, R equals negative 2. Okay? So basically, maximum R value is equal to 2. So same thing. So what you're looking for here is how far away is the maximum from the origin, from the pole, right? And that distance is 2. So at the 2 pi over 3, when you plug in 2 pi over 3 here, you're going to get 2 cosine of 2 pi, which will give you positive 2 again. Okay? So if you want, sorry, I'll take you in a minute. If you want, when, so if you do it like R and theta, when theta is 0, R is 2. When theta is pi over 3, R is negative 2. When theta is 2 pi over 3, R is 2. Yeah. Hmm? Oh, yeah. Because I was thinking, yeah, pi over 3. Okay, so here, let's graph this guy. So when theta is 0, okay, so I have 3 petals. When theta is 0, R is 2. When theta is pi over 3, R is negative 2 here. When theta is 2 pi over 3, R is 2, right? And it's 0 in between. So honestly, if you're using symmetry to graph these, I'm okay with just this. Okay? All right? So this is like the shortcut. So now, like look at this where it's like the most, where it's like the more, precise, point by point by point, if you're given this. Whereas here, whereas here we're putting the big ideas together. Okay, I have a rose with 3 petals. The maximum is at 0 pi over 3 and 2 pi over 3. And the maximum R value is 2, so that's how it looks. Okay? All right, yes?
Why?
When it's R, it's a lemniscate. When it's R squared equals blah, 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 we have a lemniscate. It was hiding. We have a lemniscate. So, again, we have to do symmetry. All right? So first, let's do polar axis. And for polar axis, remember here, what we said for the polar axis, we have to change theta to negative theta. So let's do that. I get R squared equals 8 sine negative 2 theta. That means R squared is equal to negative 8 sine 2 theta. Did I get my original function back? No. So it's not symmetric around there. I'm going to move the lemniscate here.
But that means that it is symmetrical.
Okay, we're going to try all of them. Now we have theta equals pi over 2. For theta equals pi over 2, I change R to negative R, theta to negative theta. So I say negative R squared. Is this equal to 8 sine negative 2 theta? R squared is negative 8 sine 2 theta. Nope, doesn't work. Now against the pole, here we only change R to negative R. Is negative R squared equal to 8 sine? Do we get the same function back? We do. So it's symmetric around the pole. R to negative R. Okay? Okay. Now for the zeros. This is a sine function. Where is sine equal to 0? When the angle is equal to what? Sine. 0, pi, 2 pi, and so on. So I say, okay, so here's what I'm going to do. I'm going to set the whole function equal to this, equal to 0. So 0 is equal to sine 2 theta. Sine is 0 when the angle is equal to 0, pi, 2 pi, and suppose I don't know how many to do, right? 3 pi, 4 pi, and I'm going to do one more, 5 pi. Okay, let's see. Theta equals 0, pi over 2, pi, 3 pi over 2, 2 pi. I already hit 2 pi. That means I don't need that anymore. Okay? All right. I see some. Oh. So sine is 0 when the angle is 0, pi, 2 pi, right?
Yeah.
So you do 2 theta because the angle here is 2 theta. You do 2 theta equals 0, 2 theta equals pi, 2 theta equals 2 pi. Then you, well, you're picking all the points where sine is 0. So now for the radius. Okay? Okay, so here's how I do this. Here's how I, Miss Malik, can do this. Maximum radius. Maximum radius. This is a sine function, right? So I ask myself, sine of theta is equal to plus or minus 1, where? At theta equals pi over 2, 3 pi over 2, and so on. Now, my function here, okay, my function here is sine of 2 theta, right? So 2 theta has to equal to pi over 2, 2 theta, 3 pi over 2, 2 theta, 5 pi over 2, 2 theta, 7 pi over 2, and so on. Okay, now what shape was this? A lemniscate, right? This is a lemniscate, so it's r squared, right? That means r is equal to what? R squared is 8 sine 2 theta. R is equal to plus or minus the square root of 8 sine 2 theta, correct? That means this must be positive. Okay? So now, if I put pi over 2 in here, do I get positive?
Yes.
Wait, did I not put those? No, I did. Okay, if I put pi over 2 in here, right? What do I get? All right, so let's do this. What is theta equal to? Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So now, if theta is pi over 4, here I get 8 sine pi over 2, which is positive, right? So that works. If theta is 3 pi over 4, I get 8 sine 3 pi over 2. Is the sign positive or negative there? It's negative there. It's undefined, so I throw that away. Yeah.
Why are you putting in 8 sine pi over 2 not pi over 4? Do you divide it or just theta, not 2 theta?
So, all right, so theta. So theta is pi over 4, and my r is 8 sine 2 times theta. Okay, so that gives me 8 sine pi over 2, which is a positive value. Okay, when theta is 3 pi over 4, I get 8 sine 2 times 3 pi over 4, which is 8 sine 3 pi over 2, and sine of 3 pi over 2 is negative. That means this whole thing is undefined. Okay? Here at 5 pi over 4, when I put it into theta, I get a positive value, so that works. But 7 pi over 4, when I put it in there, I get plus or minus the square root of 8 sine 2 times 7 pi over 4, which is 7 pi over 2. It's here. Sine is negative there, so that's undefined. Okay? So, which ones work then? At theta equals pi over 4 and at theta equals 5 pi over 4. So, r and theta. So at theta equals pi over 4, when I put pi over 4 into here, right? Let's see what we get. 8 sine 2 times pi over 4 plus or minus 8 sine pi over 2. What's sine of pi over 2? 1. So this is plus or minus root 8, right? So when theta is pi over 4, my r value is plus or minus root 8. How about when theta is 5 pi over 4? How much is r? It has to be the same thing because you can't have different radii for different values. So at pi over 4, it's plus or minus root 8. And oh my God, I don't have my calculator, or do I have my calculator? I don't know. How much is root 8? Who cares, right? Because we're not sending anyone to the moon with this. But do we know between two integers root 8 is?
Yeah, 2
It's between 2 and 3, right? It's 2 point something. So at pi over 4, it's 1, 2 something, and negative 1, 2 something. And so my lemniscate looks like this. So remember, if you draw it, it goes out, 0, back out this way, 0. Okay? Yeah. Okay, this one is actually super quick here. Okay, let me take that question in after I do this one. Okay? I'll come over to you. So during a concert, a directional microphone was placed facing the audience from the center of stage to capture the crowd noise for not a love recording, a live recording. The area of sound the microphone captures is represented by this, okay? So basically, you've got the stage here, the microphone is here, and then the people are sitting, you know, all over here. And so, you know, it's going to capture voice from like all over, but as much as we think it's like a spherical area that it captures sound, it's not. It's according to this curve. Graph the polar pattern of the microphone. What kind of curve is this?
It's a cardioid.
Is that right? Is it a cardioid? It's a plus b sine theta. And when a and b are the same, it's a cardioid. Okay. What's the maximum it goes from the pole? What's the farthest it goes? What's A? 3.5. So, and now, is this a sine or a cosine function? Huh? It's a sine function. Is it maximum at pi over 2 or 0? At pi over 2. So at pi over 2, sine of pi over 2 is going to be 1, right? So it's going to be, I'm sorry, it's going to be 3.5 plus 3.5 sine theta, so it's going to go over not 3.5 but 7. So if we go 2, 4, 6, 8, this is about 7. At pi over 2, it's going to go over there. Now, what does a cardioid look like? It's like a heart, right? So its pole is here, and it's going to branch out like this. Okay? So I did a very rough sketch of a cardioid. Okay? But pretty much, if this is where the microphone is placed and this is where the audience is, those are the people whose sound this microphone is going to capture. Okay, how cool is that? Right? So like if somebody is sitting here, their voice is not going to be captured. Like if somebody is sitting just outside here, their voice is not going to be captured. Sorry, buddy. Okay? So isn't that cool? Why aren't you guys so excited about this? Like look at how it's like it's a mathematical graph, right? Yes. Yeah, so basically it's a live recording. Like it's actually like when they clap or when they cheer, right? It's taking all of that. You know what I mean? Exactly. So the singer falls in here, right? But so does like the audience. Yeah. Yes, Gabe.
At 0, is it touching 0, 0? Like the orange?
Yeah.
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 For the like math, you just put 1 or like basically say
Right, because at pi over 2, sine of pi over 2 is 1. 3.5 times sine of pi over 2 is 3.5. Plus 3.5 is 1. Eli?
Where is the start of, like, where's the microphone?
Here, at the origin. At the pole. So, what does this tell you about the microphone? That basically, what's the farthest north that it's going to pick up sound? Right. So it'll pick up sound up to 7 units directly ahead. And now, on the sides here, right, when theta is 0, sine of 0 is 0. So how far does that go? 3.5, right? Picks up sound up to 3.5 on like the lateral sides. 3.5 units. Okay? Oh, shoot. On the axis, like on the...
That's what you use the radius for?
Just a sec. So basically... we're looking at the maximum and the minimum value.
Okay.
The maximum value happens at theta equals pi over 2, and it reaches up to 7 units.
Okay.
But here, when theta is 0, right, that's the minimum value. And when you put it inside your function, right, when at sine of 0, this is 0, so it only reaches a maximum of 3.5. Okay? All right. So I'm gonna, okay, so that's that.